we're going to get into the chapter 1 and 2 proofs practice, okay? I'm just going to do 2 examples here for you. Feel free to pause the video and copy down these essentially word bank that we have of all our properties and definitions from these 3 sections that, again, we covered these in Module 1. We're just revisiting how to use these in proofs. So I've abbreviated mine a lot. So if you don't know what the abbreviation means, go back and look at the different 4 groups given in this packet just previously, and you'll find those. Or if the abbreviation I like to, it's a little bit shorter, don't have to write quite as much. If you know what the abbreviation means and it's clear, you're welcome to use these as well. I also wanted to point out the symmetric property of equality. Remember, that's what POE stands for. And symmetric property of congruence. Those are the same property. One is just whenever we're using equations and equal signs, and the other one's when we're talking about figures and using a congruent symbol. If you aren't that specific as to whether or not you give the POE or property of congruence, if you just write symmetric and that is the appropriate property, that is sufficient for this class, okay? All right, so let's try a 2-column proof. All right, so remember, we always start a proof with what we are given. So given is the reason, and we need a statement to say what exactly we are given. So in this one, there is something in words that says given, and remember, anything in from the picture is also considered a given. So we are given this. JN is the segment bisector of AP. So we are just copying exactly that. It's given, okay? Their next step here is to say that AJ equals JP. So how do they know that? So how would they know that AJ equals JP? Well, from what we were given, we were told that JN is bisecting, right? It's a segment bisector, so that means that bisect is cutting this segment into 2 equal halves. This half is equal to this half. So there was kind of a key word in the given that allowed me to go from here to here, and it's this, segment bisector. And that's one of my, essentially, definitions, postulates, whatever, okay, from my word bank. Definition, segment bisector. So I'm going to put that there. Okay, so remember, my last line should be what I'm trying to prove. So I'm trying to prove that AJ is congruent to JP, and you might again say, well, wait a second, isn't that what number 2 says? Careful. This one doesn't have the segment symbols and it has an equal sign. This one does have the segment symbols and it has congruent symbols. So what allows me to go between equals and congruent? Remember, what this says is the lengths are equal, therefore they're congruent. And that is the definition of congruent. It means if they are equal, then they're congruent, or if they're congruent, then their lengths are equal. So because we're talking about segments, this is definition of congruent segments. If you, again, just put definition of congruent, that would be okay. This one is more specific for this example, okay? All right, guys, I'm going to do number 3 next here. It's a little bit longer one. Okay. It says, given L is the midpoint of KM. So they have that statement filled in. I need to fill in the reason. Well, I know that is given. So I always like to essentially start and end my proof and then work on filling in the middle. So I know that L is the midpoint, that's given. And then I know I need to end my proof with what I'm trying to prove. So I need to prove LM equals 10. Okay? All right. So I'm just kind of filling in the blanks, and I want to go step by step from knowing LM is the midpoint of KM to LM equals 10. Okay, and it says draw a picture. Sorry, there's not a ton of room in this packet. I'm going to draw it up above. So we have KM, and L is the midpoint. So if it's in the middle, I know those 2 sides are equal, right? And that's actually the first thing that they go with. They say, then, if L is the midpoint, then KL must equal LM. And that's because that word midpoint, right? Because it's the midpoint, I know that's why those 2 sides of the midpoint are equal. Okay? All right, now here, I have another given. You could have stated this all up front. They chose to do it a little bit different. That's okay. Usually I like to do all my givens first. As long as they're there, we're good. So I have another given. KL is 5x. So I'm going to add that to my picture here. KL is 5x. LM is 12 minus X. Okay, so then they're saying, okay, use substitution with what we already know to write an equation, right? We're trying to find X. So I know that KL equals LM, and KL is 5X. So instead of KL, I'm going to replace it with 5X. Instead of LM, I'm going to write 12 minus X. So I'm substituting 5X in for a KL, 12 minus X in for LM. So that's why that's the substitution property. Now they say use the addition property of equality. Okay, well, the only thing I can add that would make sense for solving, right, is I would want to add the x's to get rid of them on one side and get them all together. So those are going to cancel. 5x plus x is 6x equals 12. Remember, anytime we're just doing the math, that's simplifying. Now they're dividing both sides by 6, so that is our division, POE. Okay, so 6 divided by 6 is 1x. 12 divided by 6 is 2. So we just simplified, we did the division. Okay. LM equals, so they're telling me to use the given one more time. So remember, anything from our picture is given, and from the words we were told LM is 12 minus x initially. So now we know x is 2, so we're trying to find LM, so we're plugging in 2 for x, and then we get 10. So plugging in, remember the formal word for that is substitution. So substitute 2 in for x, 12 minus 2 is 10. All right, guys, we're going to kind of continue working through these practice proofs. They're going to start here where some of it's filled in for you, and we're going to try and get to the point where none of it's filled in. But don't worry, we're going to kind of build up to that. So there's a couple examples for you to get started, and then we'll work on some more in class together.